Hello everyone, good morning. In this session we are going to discuss types of core. Those are nothing but core type and shell type. So these are the basic differences between core type transformer and shell type transformer. So these are the basic two types of cores, that is core type and shell type. So coming to the cross section, the cross section may be square. This is square type construction. This is square type construction, or we can say that cruciform and three step, or it may be like this, or it may be cruciform or square type, right? So coming to the shell type transformer, the cross section is rectangular in shape. It should be in the form of a rectangular shape. This is the shell type and this is core type. So coming to other differences, the windings surround the core. Means here the core is surrounded by this winding. This is the winding. Here the core is surrounded by the winding. This is single phase and this is three phase. See, this is the winding, right? This is what? Core. Here the core is surrounded by the winding. Simply the winding surround the core. So coming to shell type transformer, the core surround the winding. Here shell type transformer, the winding is surrounded by the core. Winding is surrounded by the core. So here we have what? See, this is the winding which is surrounded by this core. Means winding is not visible in case of shell type transformer. Coming to core type transformer, this core is not visible, which is surrounded by the winding, but coming to shell type transformer, the core is surrounds the winding. Coming to lamination shape, what we have discussed, this should be in the form of square, right? That is, this is one section and that is another section. So these two sections can be tightly coupled. Obviously we are going to get this type of square construction of core. So by using screws, you can tightly rivet it to get this square type core type transformer. So coming to shell type transformer, this is in the form of rectangular, right? So this upper part is easily removable by removing screws. So the lamination are cut in the form of long strips of E and L. So how many limbs we have? 2 limbs. Here we have 3 limbs. 2 limbs means what? This is 1, this is 2. Coming to shell type, this is first limb, second limb, this is third limb. So coming to this insulation point of view, more insulation is required for core type transformer and less insulation is required for shell type transformer. So coming to copper requirement, insulation requirement is more. Obviously the copper requirement for the winding is more, like that the copper requirement for shell type transformer is very less compared to core type transformer. And winding arrangement, the primary and secondary winding are placed on the side limbs. So this is the first limb, this is second limb. So coming to shell type, this is first limb, second limb, this is third limb. So in case of core type transformer, the winding is placed on both the limbs, for first limb as well as for second limb. But coming to shell type transformer, the total winding is placed in the central limb, that is second limb. The primary and secondary windings are placed on the central limb. So this type of winding is called concentric winding or cylindrical winding. See, some part of the portion is from primary to secondary, like that. See, this is primary, primary, some part of secondary winding is present on both the limbs, right? That's why this winding is called concentric winding or cylindrical winding, and another name is nothing but interleaved winding. Another name is nothing but interleaved winding. Some part of the winding is present between the two limbs, whether it is primary or secondary, same amount of winding is present on both the limbs. But coming to shell type transformer, whether it is primary or secondary, same amount of primary or secondary winding, or and same amount of primary and secondary winding is present in the central limb. This type of winding is called sandwich winding. Sandwich means what? Some part of LV winding and some part of HV winding. Again LV, again HV, again LV, again HV. So this type of winding is called as sandwich winding, or you can name it as disc winding. And what is the flux distribution? So same amount of winding is present on both the limbs, whether it is primary or secondary. So the flux is equally distributed on the side limbs of the fold, right? Coming to shell type transformer, central limb is carry the whole flux because we are providing the winding in this central limb, that is second limb only, central limb. So obviously central limb carry the whole flux and side limbs carry the half of the flux. Simply the same, let us say this is 5 by 2, this is 5 by 2. So obviously this is 5 by 2, this is 5 by 2. 5 by 2 plus 5 by 2 is nothing but what? 5, right? So this central limb carries 5 amount of flux, but coming to side limbs 1 and 3 carry half of the flux. But here half of the flux, or you can say equal amount of flux. Equal amount of, why it is half of the flux with respect to, because this first limb is consisting of primary and secondary winding, like that the secondary winding is called second limb consists of primary and secondary winding. So obviously limb 1 like that, limb 3, limb 2. Limb carries half of the flux, limb 3 carries half of the flux, limb 2 carries same amount of means total flux, which carries total flux. Sorry. So this is the flux distribution, and these are the other differences. Coming to magnetic circuits, how many limbs we have? Here we are providing the windings in between two limbs, that's why two magnetic circuits, 1 and 2. But coming to shell type transformer, we are providing the winding in central limb, but the flux distribution is for first limb and third limb is half of the flux, but coming to central limb, that is total flux, obviously 1 and 2 and 3. Sorry, yeah, only in the central limb we are providing total winding, right? Primary and secondary. That's why how many magnetic circuits in shell type transformer? That is 1. But coming to core type transformer, that is only 2. Losses, obviously core type is having more losses, shell type is having less losses. Maintenance is easy for core type. For shell type transformer it is difficult. Why it is difficult? Because we are providing the winding in the central limb only. So in order to provide the winding, we have to open that shell type transformer, because the core is surrounded the winding. That's why the maintenance is very difficult for this shell type transformer. Mechanical strength is low for core type and high for shell type, and output is less for core type and high for shell type. So coming to cooling, does not exist for cooling, and coming to shell type transformer, this is exist. And coming to application, it is economical for high voltage and low current applications. High voltage and low current, HVLC. But coming to shell type transformer, this is for low voltage high current, LVHC. and leakage flux is more in case of core type transformer. Leakage flux is less. Why it is leakage flux is less? See, because we are providing two windings on either two limbs, because some amount of flux is leakage flux. Leakage flux is available in the air. With respect to this winding also, half of the amount of flux is available in the air. But coming to, we are providing the winding in case of central limb. In case of shell type transformer, we are providing the winding in central limb. Obviously, that leakage flux is available within the machine. Available within the machine. Phi L1, Phi L2. This leakage flux is helpful to drive an application, or which is helpful to provide an EMF. But coming to core type transformer, the leakage flux is available in the air. But coming to shell type transformer, that is present in the machine itself. That can be useful for induce an EMF. So coming to core type transformer, this is the placement of winding. See, some part of the LV winding, LV, over that we have HV, and like that LV and HV. See, by using LV winding nearer to core, we get saving copper winding, so size, cost and weight of the transformer is reduced. But coming to shell type transformer, what is the placement of winding? Sandwich winding, right? Sandwich winding, that is LV, over that LV HV, again HV. But half of the LV winding, over that half of the LV winding is provided. For example, LV, HV, HV, if you provide LV, here it is also LV, then we have to provide HV by 2 or HV by 2, like that you have to provide. So to improve the stability, bottom half divided again into two halves. So in order to provide the stability, whether it is LV or HV, bottom half of the winding should be divided into two halves. So because of this, symmetrical distribution of flux is obtained, so that equal forces are obtained, which leads to the machine is mechanically stable. So these are the two types of cores, that is core type and shell type transformer. These are the advantages as well as disadvantages of these transformers. Thank you.